What's up, everyone? Welcome to yet another episode of TST Garage Talk. I am your host, Ron.
And I'm your co-host, Mark. And today we will be installing and testing how long a 3D printed sprocket will last on our Honda Grom.
For science!
Oh, there it is.
I think that's the end of that experiment.
So as some of you may know, we recently released our line of aluminum lightweight Honda Grom sprockets. These sprockets will fit all 3rd-generation model of the Honda Groms. They're a killer upgrade. If you want to check out more on that product, be sure to check out our product feature video, which is in the link below, or you can stop by our website, tstindustries.com yet again.
Now, when it comes to developing any product that we release here, we usually start prototyping on a myriad of additive manufacturing machines that we have, 3D printers, if you will. We use these to help us nail down geometry, fitment, aesthetics, all before our products go to mass production. We use these to develop just about anything here, whether it's these sprockets you see before you, carbon fiber exhaust tips, even taillights. These machines are incredibly valuable and efficient for this entire process that we use here at TST.
And as you can see before us, we have 3 sprockets, all made of different materials and using different technologies. The first one we're going to start off with is probably going to be the weakest. This is an FDM machine, ABS 3D printed sprocket. We don't believe this one will last too long. This is actually printed in a pretty big FDM machine and is printed flat. But moving on, you can see we have this clear 3D printed sprocket. This is actually, we used a resin printer for this one, and we had a much smaller printable surface area, which led to us printing in a diagonal manner, and which is why you see these supports on the back. Technically, every 3D printed material does need supports because you can't print things in midair.
Or can you? Take into consideration this SLS machined product. This is the sprocket that was made in our SLS machine, which is a kind of complex method, but it's really not when you break it down. Essentially, you start off with a block of powder, and then a laser comes in and superheats the powder and fuses it together. So you have a laser sintering method to adhere all of this together, and we believe this is going to be our strongest product here, just because of how it's made, how tough it is, how thick it is. This is going to be, we think, the longest lasting one.
Sharks with freaking laser beams.
Sharks with freaking laser beams made this. We do use the SLS machine, this laser sintering technology, for quite a few products that we make. Most recently, our Ninja 400 Airbox, also our Velocity stacks that you may have seen, and then a few different spacers and adapters that we use for some turn signals and other mounting hardwares.
That process is actually pretty durable and
it
tensile.
It is, yeah.
We do think, as Ron said, this one will last the longest. We do believe that this resin one will be the 2nd strongest. And it is important to note that there are several other additive manufacturing or 3D printing technologies out there. We are not discrediting the strength or durability of any of those or the range that they can print. However, we are only discussing, testing, and showcasing the technologies that are available to us in-house.
Sure, yeah, absolutely. We're gonna just make use of what's convenient, and we kind of already ended up with all of these random sprockets laying around, so why not use them to test it out? How are we going to test these out?
So to begin, we are going to throw the bike up on the, well, it's on the lift behind us. We're going to put it on a rear stand. This will be infinitely easier, as we are going to be using our TST spooled captive chain adjusters to lift the bike up, and we won't have to be fighting with the pesky OEM chain adjusters. If you want to check out more on those products, this is a nice little plug. Be sure to stop by our website, tstindustries.com. Link is in the description as well. But we will test the bike, test these sprockets with the bike on a rear stand with no load. This will help free up any dead weight by the bike, making it hopefully much easier for these sprockets to last.
Yeah, I think that will definitely be the path of least resistance, if you will.
And then moving on from that, if any of them last, or if all of them last, we plan on actually taking them out onto the road, and hopefully I don't get any chain slap on my leg.
Yeah, not it. I'm not riding the bike.
We will throw the bike in 1st gear and maybe up to 2nd gear, who knows, and see just how long these 3D printed sprockets do last under load and under normal stress with wear and tear.
With all that said, do you want to slap one of these on?
Let's do it.
Let's go.
So with the sprocket installed, this is the ABS 3D printed sprocket. Let's go ahead and turn the bike on. Let's throw it into gear. Looks like it's doing pretty good with no real weight. Let's give it a few revs. And as we saw, that sprocket did last with no load. We did obviously rev it up quite high, but without any weight and without any real resistance on the wheel and the drivetrain, it lasted pretty well. So let's go ahead and take it to the road and see how far we get, literally.
All right, guys, we have got the ABS sprocket installed. We got GoPros on this thing. Mark is in his safety gear. He's got suit, he's got helmet, gloves, boots, everything to keep him safe as we try this experiment. We urge you, please, please, please do not try this at home. We do not recommend this. We probably shouldn't even be doing it anyway, but we're gonna find out for you guys and for science. So we're going to wheel this out to the road and we're just gonna see if the sprocket will hold up for like a minute. We're gonna give Mark a timer. We're gonna not have him go too fast. We don't want this thing exploding on him, locking up the rear tire. That could be bad. We're just gonna see how long this thing will last. So without any further ado, let's go check it out.
All right, here we go. Well, so as you all saw, nothing happened. We took it pretty easy. I did get up to 67 kilometers on our Grom, roughly 41 miles per hour. After that, I felt a little unsafe just because if it did break and it did seize up the rear wheel, I would have high-sided to the moon, and I really wasn't trying to do that. It's also starting to rain a little bit, so I think we're gonna call it quits for today. Obviously in this video, it's only gonna be a half-second cut, but we're gonna pick back up. We're actually gonna take this bike to our dirt track and try and give them a few equal lap times, see how many laps we could complete with each of the Sprocket prototypes we have, and hopefully some destruction happens. And if not, it does go to show the different capabilities of 3D printing and the different processes that you can choose to 3D print. So stay tuned, we'll catch you guys in the dirt.
All right, guys, we are here, day 2 of 3D Sprocket testing. Now, we are still using that 3D printed ABS Sprocket made on our FDM machine. We found out it worked just fine out on the road, not going too fast, about 40 miles an hour. But let's see how it handles out here on the dirt. We're gonna put it under a little bit more load. There's some jumps, some bumps, some dirt, some grime. We're gonna put this thing through the ringer. Now, our goal here is to try and knock out 5 laps. So we can see how long this lasts. Each lap's about 1/3 of a mile. If it lasts the 5 laps, we'll go ahead and swap to the next sprocket and the next sprocket. And if they all make it through the testing, we're gonna take them off, inspect them, and see how they held up. So without any further ado, Mark, take it away, man.
think I'm done. I am done. Done. All the teeth are gone. All the teeth are gone. Huh? Yeah, all the teeth are gone.
All right, so after 5 laps, we no longer have teeth on our 3D printed sprocket from our FDM machine. We thought this thing was going to shatter. It didn't. It actually held up pretty well. Mark was out there ripping it pretty hard, sending it through up and down in gears. So I would say that was a success, all things considered.
I don't know if the footage caught it, but I think that one tooth probably broke off sooner, and then it just caused every other tooth to
that seemed to be the demise. Yeah, we noticed one tooth after we pulled in was kind of cracked and hanging. We decided to keep going to see how long it would last. It was only a lap or two later that there were no more teeth. Mark was just gunning it and the bike was going nowhere. The chain was just spinning around the sprocket. Nothing was happening. So with that being said, we're done with that one. We have now installed our resin printed one from our Resin 3D printer. We thought this one was gonna last a little bit longer, but upon installing it, it just felt brittle. It felt as soon as I put those nuts down and tightened them down that this thing was going to crack. We're going to take it easy. We're going to do the first no load test here, and then we will take it out onto the dirt track and see how that goes. So God, come on guys. All right, so we are going to go ahead and test the resin sprocket with no load, so up on the rear stand. So Mark, if you want to pop it in first gear and see how she rides. Well, seems to be holding together quite well. So Mark, if you want to go ahead and get fully suited up, we're going to take this out on the dirt and see how long it lasts. Let's go.
Well, we made it 1.5 laps, and that was it. Teeth already broke off. It caused the chain to skip, broke our GoPro mount. So let's wheel her in and get this swapped over.
All right, so after some slight modifications, we did get our laser sintered sprocket installed. We already are noticing some slight warping on it. We're not sure how long it's gonna last, but with it being installed, we're just gonna go out there, do a quick freeload test here, and then we'll go out on the track, see how long it lasts. And then if it makes all 5 laps, we'll head back to the shop and do a final look over of all the sprockets and kind of compare results. But for the time being, let's go ahead and see how it does on the rear stand. Spinning, that's good. Some load, some higher RPM. Perfect. All right, let's have Mark get suited up. We'll head out to the dirt track, see how long this thing lasts.
What caused it to hop off?
Oh, just probably a broken tooth. Oh, dude, the teeth are, I mean, they're shredding on the insides. The whole inner lip is just...
All right, well.
I think that's the end of that experiment. Cool. Oh, yeah, dude, they're like splayed open on the back here. That's crazy.
All right.
Cool. Well, thanks for not crashing. All right, guys, we are back from the dirt compound. Mark, thank you for putting your life on the line. At any point in time, did you feel sketched out?
Absolutely.
Yeah, the whole time?
Immediately.
The whole time?
So this was all brought on, honestly, by us testing this before.
On accident?
On accident. I forgot that there was a 3D printed sprocket on the Grom, and I was like, oh, I'm gonna go ride it to the gas station, and I got 3 feet out the door, and it just broke.
It exploded, and I think that was kind of what fueled the idea for this, and also kind of steered our predictions. I don't know if you recall at the beginning of the episode, we had made some predictions, how we thought these things were going to hold up, the longevity of them. We were dead wrong. Yeah. We couldn't have been more wrong, I feel like.
Yeah. I mean, the proof is in the pudding, in the footage.
It is.
We were absolutely wrong. I wish I could go back and change my guesses.
Yeah, I mean, we started off by, I mean, we'll go in the order of which we rode the sprockets. We started with the ABS sprocket made in our FDM machine. we thought this one was going to explode immediately because that's what that first one, the incident you had just brought
Yeah.
up, that was the one that was on there. However, that one had the cutouts. It was very similar to our actual Sprocket.
Yeah.
It had these cutouts. So we made all of these. We beefed them up a little bit. We filled those holes in. We thought this one was going to explode. It made it all 5 laps almost. It made it almost all 5 laps. We noticed at one point a tooth had chipped. It was kind of falling off, and then it seemed like it was a domino effect after that. Ta, 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 ta. So tell us a little bit about your experience riding around on a plastic Sprocket. We started out on the street, then
so
we went to the
starting
dirt.
off in the street, I took it easy because, like we said, initially when this happened accidentally, we tested with the same material. So I took it pretty easy. It didn't break, so I said, full send, boys. It's Saturday, let's go. And nothing happened up until the very end. I really do believe that heat played into it more than force or torque. I think it had a little bit of an effect, but I think that over time it heated the material up and probably made it weaker. I'm no rocket scientist.
Yeah, it's a good thing we're not on the engineering team, seeing how our predictions went. You're the stunt guy. I'm just here to kind of help you along. But again, we were surprised by the results by this. By no means should you be making your sprockets in a 3D printer. I think we can suffice to say that.
And within these parameters.
Sure.
Again, as we said in the intro, there are a plethora of printing materials and printing methods. You can print in steel. They're printing houses in concrete. You can print a sprocket that is durable and lasts out of steel or aluminum. We do not have access to that in-house, so we printed with what we have access to and knowledge with. So if you're, for the everyday Joe Schmo who bought a 3D printer off of Schmamashmon and or Schmeebay and they want to print a sprocket, don't do it. Just get a better material.
Yeah, they do make like alloys. Bart had even mentioned, if you guys want to see us print with some other crazy materials, test out other products, we can do that. But speaking of other materials, other ways of manufacturing, let's go on to the resin one. We thought this one was going to last a lot longer. This one almost didn't even make it the first lap. I think there was some initial failure, and then it exploded.
In the quick synopsis, we did say, like after we installed it, we felt how brittle it was, so our prediction kind of changed. And going on the footage, when you watched it, you see that on that first lap, I'm going very slow. One, because I wanted to give him time to get on the Grom and follow me on that secondary cam, but mostly because I was actually terrified that this one would break. So I decided to go pretty slow to start up. I made it a full lap, and then on the entering the second lap, I decided to pick it up slightly, see what it could handle. And voila, it detonated.
Yeah,
like
it exploded. It's in pieces. We coincidentally lost a GoPro at the same time. I don't know if that was related. I don't know if those two were combined, but this test ended very, very quickly, and surprisingly. But that led us to our very last test. That's the sprocket that was made in our laser sintering machine, the SLS machine. This one seemed to have failed because the teeth, the profile of them, seemed to just wear away very quickly. I don't know if that's because this is a powder that's been solidified and it just kind of wore away at it much quicker than these other two products. But this one, again, it went out very quickly. It didn't shatter, but the chain kept popping off.
It is also important to note that, as you saw, we had to modify this one due to printing issues, which aren't super common, but a quick disclaimer on 3D printing anything, issues can arise. Your material can get clogged, the printer can disconnect, it can miss a layer or skip a layer. There are so many issues that can happen.
You can have scaling issues, which is what I think happened with this one most
so this one, we had to modify it. It was warped. As you said, the teeth got all splayed and frayed out. Ultimately, the chain just couldn't retain on the sprocket, and it just popped off. So I actually felt pretty good riding this one. I was like trying to give it the beans, and
you seemed surprised when it broke down. You were like, well, "What's going on here?"
I thought I messed up.
Yeah, no, and the changes didn't want to stay on. Which again, this is why we don't make sprockets out of these. But to summarize it all, Mark, thank you for putting yourselves on the line. You came back in one piece. Our sprockets did not. But that's okay. That's what these tests are for. You did it for the viewers. You did it for science, and we couldn't appreciate you more. So thank you.
Absolutely.
Again, if you guys want to see us test some more products in this range and these parameters, let us know. We're willing to put Mark out there and to see him get injured. We don't mind. It's a risk we're willing to take.
I did not sign this contract.
It's okay, we'll get there. And all in all, you know, we made these, we went through the testing process, we dialed in aesthetics, and we did end up with this super nice lightweight sprocket that we have. And if you guys want them, check them out on our website, tsdindustries.com. They're a killer upgrade for your Grom. Any last words, any advice for the viewers when it comes to testing these?
Yeah, don't 3D print any crucial components and try and ride your bike. Mirror block offs, yeah, sure, go for it. Little accent pieces, absolutely. You know, motor mounts, probably not. But in any event, design, create, have fun, explore your creative side and ask questions, and scientific method, test, and
Absolutely.
that's what put us in business and kept us here. So
Definitely. So again, thank you guys for watching. We do appreciate it. If you found this video interesting, subscribe if you haven't already. Leave a comment below if you enjoyed it. You want to see us test some other sprocket, other materials, other items, other products, levers. Maybe do a 3D printed rotor. Would you feel safe with
let's
that?
3D print a wheel.
Maybe. Stay tuned. Let us know. I'm Ron. This has been Mark. Thank you guys so much. Ride safe.
Just here for the ice cream.
Stop.